Are we ready? Get started. Cassandra at Hulu. Let's talk about some extreme availability. So, a show of hands, how many people use or have Cassandra deployed across multiple data centers? Okay, those are good handful of people. Right, so I'll talk about some of the nuances that we've encountered with that, and hopefully you can learn from some of our mistakes. But besides that, I'll also cover some other general availability concerns. A little bit about myself. I'm Matt Jarrett. I'm a software developer on the core services team. I've been working on core services for about 3 years now. We deal mainly with a lot of real-time services, particularly with user-generated data. So you can kind of naturally see the fit there, where we have scalability concerns, trying to serve queries very quickly and stay available all the time. Some of the things we'll look at, I'll give you a quick glance at some of our clusters, kind of what the versions we're running, kind of the hardware configurations that we've chosen, that sort of thing. From there, we'll look at the application level guidelines, some things that we want to keep in mind as we're rolling out new applications. And then finally, some operations that we perform on the clusters, more maintenance tasks, that sort of thing. So overall, one of the objectives I want to kind of convey here is to plant some seeds of thought in your minds, and just trying to convey some of the things that we're thinking about as we're using Cassandra. Okay, our clusters. We have several clusters. Cassandra is not particularly good at multi-tenancy, so kind of have some clusters that are single application running on them. And then we have others where there's a few smaller applications that we can kind of throw together. But overall, we're using the very latest of the 2.0 branch, 2.0.12. We very recently upgraded, actually. That's what we have the graph here is. The graph specifically is latency as observed from one of the services that's using Cassandra. And the latency is essentially just the time to do a very simple select. Select a partition and get back a whole bunch of rows. So right after upgrading from 1.2 to 2.0, we did actually see a pretty good drop in latency. This is, the blue line is the previous day's latency at the same given time of that day, and then the green is the day of the upgrade. And right as we performed the upgrade, we got a pretty good boost. So, kind of a nice surprise that we encountered. Running Java 8, it's probably not recommended. I know it's not recommended, but it works. There's really no great reason to use Java 8 from Cassandra side. It's more for our internal purposes. We have uniformity across all of our servers, that sort of thing. And it's true, it does work. We have not encountered any issues there. The other surprising thing there is we're using G1GC. I'm sure people have run across various garbage collection issues and playing around with concurrent mark and sweep parameters and so forth. We went through that hassle as well. And at that point, we had figured out some settings for G1GC that actually competed pretty well against CMS. And we can get very, very stable garbage collection times. In fact, it ends up being more efficient in some cases than CMS, we found. So it's working out well for us. And finally, last one here is our largest cluster spread across 2 data centers. We have 16 nodes in each DC. So what do those nodes look like? Well, initially we went with something we called our Hadoop class machine, and that was your standard spinning drives, really massive, ended up being like 18 terabyte total per node. We quickly realized that Cassandra can't get anywhere near that utilization. And ultimately, the read latency was really, really bad because we didn't have enough RAM to cache all of the data in memory. So we had to go to disk very often, and 7200 RPM drives are really slow to pull stuff back off disk. So that did not work for us. The next iteration we went to were same essential chassis, but we switched to SSDs, and that configuration was, initially we used 300 gig SSDs. We've since upgraded to 4, and we put them in RAID 5. RAID 5, there might be some moans and groans about why we're adding an additional layer of redundancy on top of the various replication that Cassandra does and whatnot. I'll say RAID 5 makes life easier. It's very, very easy to swap drives out. We can grow the volumes online. It helps with availability. In fact, the SSDs are very reliable. We haven't had one fail for some of our big clusters, so it works out well. And RAM, I'm sure you guys have heard the mantra. Yeah, so if the JVM doesn't take up the RAM, then the page cache will, and that will kind of shade some of the latency when you have to pull data off disk. SSDs are fast, but RAM is faster, so throw more RAM at the problem. That's the issue with that. Scaling. So scaling some of our clusters. Our main concern is storage capacity. We have more users watching more videos. We're adding more applications, so we need more storage. We're not really bottlenecked by CPU or anything else. We just need more disks. So how do we go about that? Two approaches. One, we've upgraded our existing machines. So as I mentioned, we're using RAID. So adding more SSDs online is a trivial process. So that's what we did there. Went from 550 gigs to 850 gigs, and it ended up being a very economical because so with RAID 5, initially we had 3 drives. So of those 3 drives, 1 would act as the parity, and then the 2 would have data. So really, you're only down to the storage capacity of 2 drives. Well, we already paid that upfront cost to have a parity drive, so really we just added a 4th in there, and we got 100% of that capacity exposed to the operating system. So I guess from that perspective, we had a 50% increase in storage, but we really only increased the number of disks by 1. And then the second part of that is we expanded our cluster. From 8 to 16 nodes. It's extremely easy to expand your clusters if you haven't tried so already. It's remarkably painless. And summing all of that up, you get a 200% growth with no downtime and no application level changes. That's one of the awesome features of Cassandra that we're able to do that. Multi-data center pitfalls. So we have 2 data centers, as I mentioned, that we're running Cassandra in. And coast to coast, one's on the east coast, one's on the west, we're looking at about 50 to 60 milliseconds. That's not bad, but we want to try and avoid that penalty whenever possible. And Cassandra, being awesome as it is, makes it really easy to query the wrong data center. Get into a situation where you run a query and you don't quite realize it's actually asking for data from the opposite data center that you want it from. So, how does it happen? There's 2 common cases that we've come across. We've rediscovered these multiple times, so keep them in mind, learn from our mistakes. So I'll go through each individually. The first one is simple strategy. So when you create a key space, you specify the placement strategy. So you tell Cassandra, for a given key space, how many replicas do you want to keep, where should those replicas be, and so forth. And the basic one is called simple strategy. Simple strategy just treats all of the nodes as a single data center. As you see, that's a big problem. If you have two data centers, then Cassandra suddenly blurs that line between where's West Coast and where's East Coast. And the solution is very simple. Just switch to network topology strategy. And even if you want to have a single, if your key space, you want to keep the replicas in a single data center, still use network topology strategy. You just specify one data center and the given number of replicas you want there, and you should be good to go there. I guess to clarify that point is your key space ends up being divided between the data centers, so you really don't have any control over where the replicas are. Some are going to be if you have RF3, you might have all three replicas in one data center, you might have three in the other, there might be some mixture, two in one in the other. It can be any combination of that. Network topology strategy is what you want there. And then the other one is consistency level. If you have multiple data centers, you're using network topology strategy, but your queries are still consistency level warm. Might happen pretty easily. If you start off with one data center, you expand to a second one, but you forget to update your applications and leave them as warm. What happens there is, well, you have three replicas in DC1, 3 replicas in DC2, do a little bit of math, quorum of your 6 total replicas is 4. Well, if you only have 3 replicas in each, then no single data center can service that request. You have to at least talk to both data centers to get that 4. And that's no good. We'll start seeing those 50, 60 millisecond latencies pile up as your coordinators are talking to multiple data centers. Solution is obvious there. Use the local quorum and local 1 variants. And those will it'll instruct the coordinator that when you actually execute the query, don't ask the opposite data center for confirmation. Just return it from whatever you can gather from the local data center. Rack awareness woes. This is something that also we didn't originally plan for. We were aware that Cassandra is rack aware. So if you look at the gossiping property files, which is Cassandra-rackdc.properties file, or whatever it is, you'll see 2 options. You can specify the data center and you can specify the rack. And initially, we started off with a smaller cluster, and it was only located in 1 rack. We didn't have it spread across multiple. So we had everything configured, all nice, and we ultimately expanded the cluster, and we added new nodes, but they were in different physical racks. And the situation we got into was the following. So Cassandra still thinks that all of our nodes are in the same rack, but how can we ever get away from this? And the question is it safe to add a 17th node in a second rack? What'll happen? And we'll take a little, we'll go off on a little tangent to review how replication works. And the simple case is with simple strategy. So Cassandra is obviously based off of Dynamo, and the basis of Dynamo is a ring structure. So here we have a ring of 6 nodes, all in one data center, all in one rack. And for the sake of keeping it simple, we'll say replication factor is 2. So the first step is we want to try and insert a value into our Cassandra ring. So the partitioner murmur3 or random partitioner 95, however, will ultimately take the key and yield a token. The token just determines where on the ring we should place the value. And here, so the partition says, okay, let's place the primary partition at node 1. Okay, primary partition, simple. Well, for the second case, we just walk around the ring and find where we should place our secondary replica. Very, very simple. Just keep on going clockwise around the ring until you find another node, and that'll hold your secondary replica. One more case, just say, okay, our murmur3 partitioner says place XYZ at node 5. So there's our primary replica. We walk around the ring, and we place our secondary replica at the next guy, 6. And everything is nice and hunky-dory. Okay, next part is network topology strategy. The only difference in configuration here is now we have 2 racks. And I tried to illustrate this by saying, or by coloring these nodes differently. 1, 2, 3, 4, 5, and 6 are rack 1, and then 5 is our new second rack. So again, we'll insert ABC. It points to node 1, so that'll be our primary replica. But now the difference is, where are we going to place our secondary replica? Well, network topology strategy says, okay, I have my primary replica. Now let's walk around the ring until we find another rack where we can place our secondary replica. Because we want to try and spread the load between the different racks so we have good redundancy in case one of the racks fails. So indeed, that's what it does. It'll walk all the way around the ring, get to node 5, and put a secondary replica there. And again, partitioner says XYZ, inserted at node 5, there's our primary replica, and this case is really simple. Node 5 is in one rack, doesn't have to go far to find a second rack, and there's our secondary replica. Very straightforward. From this, we can see there's 2 cases. The primary replica is going to be in either of 2 places. We're going to either place the primary replica on node 1, 2, 3, 4, 6 in rack 1, the purple nodes as I colored them, or it'll be on node 5 in rack 2. But if we look at the first case, we say, okay, the primary replica is in 1, 2, 3, 4, 5, 6, so the secondary replica is going to have to be placed in another rack, but the only option we have is node 5 in rack 2. So any secondary replica is going to land in node 5. And the second case is, okay, well, node 5 is going to be our primary replica, and well, there's our copy. That's all we're concerned about for this case. In either case, node 5 gets a copy of the data. Whether we place the primary one on 1, 2, 3, 4, 6, the secondary will land on 5, or the primary is 5 itself. So node 5 gets a copy of the data regardless of whatever we do. So back to the problem is it safe to add a 17th node in a second rack? What's going to happen? No, it's actually not safe. The 17th node is going to get a full copy of the data, and with 16 nodes, that's dangerous. Our nodes don't have enough disk space to hold a full copy of the data. We're at 16 nodes already. We're trying to scale out, so adding that 17th node is very, very difficult. It's something you have to be very careful of when you're configuring the rack awareness. And almost at the end. On that note of disk space, it's easy to kind of bump into limits there and say it's all fun and games until you run out of disk space. A good rule of thumb is always reserve 50%. There's a lot of different operations that will eat up 50%. And the way that it does this is it will double the disk space. And that occurs when Cassandra will take a snapshot of all of your data and then rewrite it in some form or another. I guess the question to ask is, does anyone know of some of the operations that'll do this? Anyone on a venture guess?
Tombstone?
Sorry, say again?
Like deleting?
Yes, delete will do that. There is the node tool will do a lot of some of those operations. There's cleanup, upgrade SS tables, all sorts of different operations, compaction, and kind of illustrate that. This happened during one of our upgrades, and I knew this was coming. I prepared for this. Don't want to go over 50% disk space, and the case here was a simple node tool upgrade SS tables will double your disk usage. What happens there is it takes a snapshot of your old SS tables. In our case, we are on version 1.2, so if you look at the file names, you'll see -IC-. That's the version number, and then we had to upgrade them to the 2.0 version, and then you'll see all the new files there, and those are -JB-. If you ever look in the file directories. So yeah, the important part to realize there is the old copy is still there in case something goes wrong, but the new copy is there that's acting as the current master set of data. It's actually being updated by Cassandra in real time. So to summarize, it's important to keep the disk usage under 50%. It makes life easier. You can push it over 50, but you have to be very careful with cleaning up your snapshots as you're doing various operations, like node tool, upgrade SS tables, that sort of thing. You also want to be careful with your topology configuration, as I mentioned, particularly with the rack configuration. Be aware of where Cassandra is going to place your replicas. You might end up wanting to put an entire copy of your data in one node. Careful of that. Embrace eventual consistency. So make sure to use local one, local form. Those help a lot with multi-data center. In fact, you can use them even if you don't have multi-data center. You can use them with a single data center. That works okay. Use appropriate hardware. Not all hardware is equal. Hadoop class hardware does not work particularly well with Cassandra. SSDs improve performance greatly, so definitely look to use them where possible. Finally, rest assured that scaling is easy. You grow in multiple dimensions, and Cassandra is able to scale, no problem. With that, any questions?